Hello there, Whisperers. Welcome back. Today, we're going to continue with our Kotlin Wasm series, where we're going to take our Android app being converted to a web app. And specifically for today, we're going to do some config changes. Number one, we're going to have our build, which is going to change from what we have currently, where everything is running from just Android source sets and incorporate common source sets. We're also going to configure our Wasm.js build from Gradle. The last thing is we're going to try to run the app once again on Android, but with shared code in a multi-platform perspective. So let's get on to it. So we're back into our build file, and here we're going to do a few things. The first one will be configuring our source sets. So let's get to that. We have Android main, Android test, Android unit test, common main, common test, Wasm.js main, Wasm.js test, all this from the last time in the video. So today we're just going to go into our build file and start a few changes. The first thing that I'll want us to put in play is the common main section. This is the part that will have all our common dependencies and will be defined as follows. We will also expect to have our test files go in here. So we're going to common test. This will be tests that are shared between Android main and Wasm.js main. We could also configure our Wasm.js main source set. Maybe I can just put this below here. There we have them. So next thing we're going to do is configuring our Wasm.js main Gradle target. We can do this within the Kotlin block. And to start, we will need to call the Wasm.js block. This will allow us to configure Kotlin with Wasm.js target. You'll notice that the IDE gives us a hint. This is an experimental DSL, so you'll have to opt into it. So let's just do that. I like using our IDE shortcuts very quickly. It is added, but sometimes I do not like opting into the whole file, just in case maybe there are sections that you want to separate from the one that is being opted into. But for this project, it is very much okay to just opt into from the file level. Nextly, we'll need to provide the name of our module that Wasm will build, and we'll do that using module name. This will intake a string of our choosing. So in my case, I'll just call this random recipes. So the web will also know this as random recipes. We also have to configure how this will work on the browser. So there's some browser configuration within Wasm.js. The first thing is we probably want to find the directory of our files, because there will be some files we'll want to copy over for Webpack. So we will look for our directory, and this is found using the project property, and then get the project directory property from project. This one has an uppercase D, and just get its path. Next, we're going to do our Webpack configuration. And within this, the first thing we want to configure is the name of the JavaScript file that will be produced when Kotlin is converted from Kotlin source code to JS that will run on the browser. So again, I'll put this with a name that is common to our project's name. So this will be our output file. this will be equal to our random recipes.js. Lastly, we can configure our development server such that we're able to see our changes as we do things here and there. So we will just define our dev server variable. So we'll redefine what we are given from the webpack config. And this will be equal to, we'll first try and see, do we have our dev server working? So is it not null? So if it's not null, just give us the same one. If it is null though, let us configure something fresh. So we'll have our webpack config. So this object does have the dev server class that you can call. So it is a, do you call them an accessible property? And we might want to do a few things for this. So let's use Kotlin's very nice apply function. And we're just going to set out our static files. So this will be again inside our static folder. If our static folder does not exist, we could just have our list, and we could add our directory which contains our project path. So this will configure wasm.js for us. The last thing actually, we want to produce executable binaries when this configuration is done with setup. So that part gives us a config for our wasm.js. The next thing I think we'll now do is we can have a rebuild. Yeah, let's just rebuild this to see if we can get that to run, and it should. So we'll wait for that import to finish. Awesome stuff. So it's imported successfully. Gradle did build, so we're good to continue. Now after this, let's go into our dependencies. So we want to move Android specific dependencies to remain on Android, and then dependencies that can be shared, have them move to common. So let's start with the most basic ones, and that will have to be our Android X libraries. So we'll look for libraries that are common. So next, let's configure our common main dependencies. We'll start with our UI. Our UI is being done with Jetpack Compose, and we do have a common version of the Android's Jetpack Compose, which is JetBrains Compose Multi-Platform. Let's start by moving those into common main. The first thing, we'll move our Compose UI. From the Compose plugin, there is a variable that you can directly access to get access to Compose UI. We also need our materials, and for this I mean material 3, not materials of materials, but material of material design. Let's continue to add the extended icons. This should be the name. So another thing, we need the Compose runtimes. So let's add our Compose runtime. So I'll just do this. I have an autocompleter here, and I would also like to add some animation. We might want to implement some animation, so let's do that. So these are common libraries that we can use. Compose UI, Material 3, Material Icons Extended, Compose Runtime, and Compose Animation. These are already defined in the Compose plugin. We can also migrate serialization. Serialization is very straightforward to get to. So let's look for our serialization items. So we have Kotlin serialization and Ktor serialization. So these two we can just remove them from here, and we are going to put them into common main. So these two are common compatible. Let us confirm serialization though from Ktor. This might be a JVM specific one, so we'll go into our version catalog. And serialization, we Ktor serialization. So this one's fine. This one doesn't have any specific target dependencies, so we're good. Another thing that we may want, Compose allows us to use resources the same way Android resources exist. To do this, we'll use the resources library. So this is Compose components resources. This allows us to use Compose resources. So either images, text for translation, and so on and so forth. So Compose allows us to do that. We could also do content negotiation from Ktor, because this is what we are using to do serialization and deserialization in our network calls. So let's again look at content negotiation. Again, this one is platform independent, so this one can also just move from here, and we'll take this here. Awesome. The other ones we will look at will be how we can move the image loading library, because my belief for this one is we are using one that is specific to Android, and so it's tied to the JVM. So we do have the multi-platform version for Compose, but the networking is not multi-platform. The networking is dependent on OKHTTP, which is JVM dependent, so we're not going to be able to use the network module, but we can use the main image module. So let's get onto that, and let's move that one first into there. The other thing also, our navigation, I have used a multi-platform navigation. So Android Access Navigation Compose is now multi-platform supported, so we can also just move that. So get that here. Let's try to rebuild this and see if our app will still run. We've moved several dependencies. So we've moved Compose navigation, coil image, Ktor content negotiation, Ktor serialization, and Kotlin serialization. So we've moved this from Android main specifically as they are into common main. So let's rerun this Gradle script and see how that goes. So our build has completed. Well, sort of not, but we ran into our first issue with a library that we tried to migrate that was not available for WASM target. Now, we tried to migrate a library that was not multi-platform. For our case, the one that we did try to do was androidx.navigation, navigation compose, and that was not the multi-platform version for navigation. We will get to that one in a few minutes. Let us put it back in the Android main source set, and then we will add the common navigation compose library, and we'll see the difference between the two. So we begin by shifting this back. This can be a good way of just knowing whether your components are working as they should or not. So maybe other dependencies had an issue, but we can tell after we rerun this part. So this build does work successfully. Now let's find out how can we use our navigation library. I'll put a link to this documentation, but you can find it on the official JetBrains page. So they have their navigation library currently in alpha, and it adopts the same approach to navigation. So that means we can almost use even identical DSL languages. So we'll see how that is. So this links us to the Android design page, but we're only interested in this one, which shows us how our common main dependency for navigation should look like. And if we look at it keenly, we will realize that our dependency starts with org.jetbrains, then the AndroidX navigation portion of the library. So let's just copy this out. I can see the version here we have is in alpha 10. So just keep that in mind. This is a library that is currently still in alpha. So you need to be careful when you're using those. Let's get that back to now common main. And the one thing I will do, I will just have this moved to version catalog. I will add common compose nav as a library. Copy out the module all the way to here. And then let's have a version reference. And we will define this somewhere here. Common nav. And the version we have is 280 alpha 10. So put that back there. Put in common nav. Should go here. And then lastly, let's get rid of this. And we're just going to say libs common compose nav. So and then rebuild our file. Awesome. Now our common navigation compiled. We will continue to try and add some other things. And we'll start by moving our UI source code into common main. Why are we moving those? Reason being, Jetpack Compose is supported on both Android and the web through WASM. And when I say Jetpack Compose, I'm meaning when it's supported on this other side, it's as Compose multi-platform. So let's start by moving our files bit by bit to see whether things will work and compile. I do advise that at this section, move your components gradually. When it comes to moving actual UI components, actual business logic, move them bit by bit. And I always suggest move one component, test it out. Does it still run? If it does not, then try and check what is the issue. Do we need to re-import? Maybe the library version that we're using from Android is not the same one that JetBrains supports. So maybe the naming scheme might be different. So that's something to keep in mind. So let's start gradually with our Android main. We go inside our Kotlin package. We do have our main activity, which contains our entire app, just in general. So it has our theme. Our theme is then put inside a scaffold, and the scaffold has several things inside. So let's start with the login page. Let's start by moving this login page into our multi-platform approach. So let's go and into our login page. Within our login page, let's just look at, do we have any other components? We do not. So let's start by moving this login component. We will go into UI, screens, and we have our login. Inside our common main, we don't have anything yet, so let's add our directory. So this will be a Kotlin source set, and then we will add a package, and this package will have the same exact name as what we had in Android. So I will just do dot random recipes. Yeah, so that's the package name. I will also give this a temporary file because I don't like it when the IDE auto completes the naming. So I'll just put a temporary file here that is called .temp. I don't want to add that. It's just a temporary file. And so inside that, there is your login, which is inside the UI package, inside the screens package. So we go in and add a new package, which is our UI. And under UI, we have, so again, for this one, let's make a copy of this temp file. Just for now, I don't want to open. I also don't want to add anything. So inside the UI package, we can add our screens package. And inside our screens package, we can move login. So we'll just move that file. We'll be given things about what we want to do with the refactor. That's up to you. Let me just do this. IDE will ask me if I want to change imports. I think there are several imports and references. So I'm being told that is referenced in this function, will not be accessible. Let's just do the refactor for now. Let's just do that for now. So I do expect multiple things to fail, which is expected because there's a lot of Android specific things. There's very many of them, and therefore is important to know that. So start from the get-go with our imports. There are a few things that are not supported. So things like the default tooling, you need to use Composer's new tooling. So for now, let's get rid of our preview. Previews are, we're not going to use them for this time. That essentially will mean we need to remove these unused imports. These are some unused imports. Another thing, inside our login page, we did use context to show some error. We had some context to show some error when the error arises, and we use it with a toast. So we have two options here. One, to either look for a different approach to running our error message, or we can find a way to provide this customly from different platforms. So that is up to you to decide, to make that decision. But for today, I will just comment this section out for the error. I'll want us to use a different approach to showing the errors. And therefore that means I will not be able to use context. Should not be able to use context. Another thing is I expect a dependency on the login view model. And so let us migrate it as well. So we have our login view model. I'm just gonna go inside screens very nicely. Refactor that. Refactor anyway. We will resolve all this ourselves. Okay, so we do have our few items. Again, there's several things that have not been migrated. So for example, our login VM requires the mail repository interface. So let's move that. So the mail repository interface is inside data repository. Data and repository. So let us move our repository package. So this is inside data. So let's first create the data package. And within the data package, we do have our fake repository and the mail repository. So actually we can just move the entire sub package. Inside network, we also have the API, which I think we can also try and move because it depends on the repository and also the models are needed. So we can just move everything from data, get them to data. So it will do its searches for, any conflicting usages and so on and so forth. I'll just refactor all of this. With IntelliJ. Also, Android Studio can help you do the same, ideally the same engine. So let's hope a lot of things are migrated well enough. But we'll also check manually for those that are not. Okay, so data package has been moved, but we are still not yet finished up with what we want to set up. So the first thing, we have our mail repository done. So let's go back to login just to see how far things are. So our login parameter is now visible. We can also check out our UI state, which is fine. You can see the compose code still remains the same. Nothing big really changes. Let us look at some other things. I can see here within the painter, this is not available. We can actually import this. But the drawable resource that we'll put, because this painter resource is from, if we can see it here, is from JetBrains compose resources. It's from compose resources and not Android X's painter resource. So let us set up our resources to make sure that things also move as they should. So to do this, we will start by adding our resources portion within our compose common main. So unlike in Android, where we have it being called res, in Compose multi-platform, we just call this directory compose resources. And then you can add 2 subdirectories. The first one will be for all our images. Our images will go into a drawable folder. So similar to how they go in Android. And then for many other things, we'll put them in the values folder. Inside our drawable folder, we also do migrate some drawables. So the first one to migrate is this one called diet. So I will copy this. Actually, I don't need to copy. I can just move it. So to drawable. Don't want it to enter, and I need to search for references. Have that in there. Then we do have strings that we have put in place here. So let's get those strings into play. So inside values, under values, we can have our strings. So they translate kind of the same way. So let's just move this here and refactor our strings. Within our strings, pretty much everything remains the same. There'll be nothing different that we'll need to do. So we'll leave that as that. Now for Compose to be able to know our resources are available, we need to always import or rebuild when you add a section of resources. So you'll need to rebuild. But we do have the downside of we cannot rebuild right now because there's some other things we need to sort out. So for now, just know that our painter resource, we can also import our string resource. This one is available for us from JetBrains Compose. So put that in there. Whatever is now left is just to take in all our resources. So this one we can build with. So let's first remove any unused imports, and also this R from Android resources should not be here. So we can also remove that. Same way where with Android, we access resources using the R class, which usually stands for resources. There's a special class for Compose as well. So we'll change all our references to R from R to a different one that we'll see in just a moment. So we will use the res keyword. So this will import our resources, and we just reference all of them here. Have all of them referenced here. Okay, so now the only thing remaining from the value that we have migrated is the actual strings. So for us to do this, we just need to perform a build. So let me just do that. So once we reload that, we can now import each individual property now. So we can have diet from drawable, random recipes. What is your nickname? Because all these are now generated. So what Compose multi-platform will do is that it will go into your file, find all the properties and things you've defined, after which it will generate them as references in your build. So that's why you have to build anytime you add a resource. So it's less ideal than I would like, bearing that I'm coming from a native Android perspective, where I don't have to rebuild. I add and it's available immediately. So that's a bit of a downside for me, but you tell me how you think about it. So we can try and run this because this file is now fully migrated. I think if we go back to can go to our login VM, which is not fully migrated. So there is the app resource from util. So let's get that done. So we go back again into util. So we're going to move this into Kotlin. So this is just a utility file. So just refactor. If it will not be available elsewhere, it's okay. Cool stuff. So this block works. There's something that's not available. So our meals route. So this was for after login. We just want to navigate to meals, and let's go find that. Let's go import that file. So login page is well good. So the login page looks okay. For the login view model though, there's one item that's still not imported. So we go back and we know that is meals route. So meals route is actually found in our meals list, meals page. Where is this? So it is here in our meals page. So we want to also move this file. But before we do, so since we moved all the strings, we might just move the whole file. I think let's just do that. So let's go here. You could alternatively do incremental changes to your importation, but for us, let's just move the whole file. So this is meals, and I will do this, refactor that. So we'll do a lot of refactoring and changing. It's not a very smooth process, but as long as you understand what's going on, everything should be fine. So we've moved meals, but now meals asks, well, there's others of my friends that you don't have, meals VM and meals screen UI state. So let me give you your VM and the UI state. So this is inside meals VM, all of them. So refactor that, get that to come in very quickly. Okay, so we go to meals. Now a lot of imports just work from the get-go. Let's change maybe our string resource. Have this as resource, and then import your file, or rather your property. We do the same here and import the property. Also, any imports that are not what we expect, get them gone. This looks like there is something that's not working as we should expect it. Of course, there's the meal details, but the other parts do work. So for login VM, this should be resolved, so we can navigate, so that's fine. So we go into meals, and this I believe is because of this meal detail route. So let's get our meal details, and since we know meal detail will require its view model, we move those, get that in. So just refactor them. Again, it's not a very smooth process. You have to be very careful on what you're moving, but yeah, it all depends on what you understood. So back to meals, and the route is now in place. This items property, we want the one that has this. this is the import that I want. Yeah, so we want the items that has an array or a list, and the one that you can provide a key with. So we've migrated all the screens. So now there's no screen in that section, and all our screens here look like they don't have an error. So let's try and run this, see whether this works. Let's execute that. So build is completed, and we do have an error. One that I did not anticipate, but I think is very straightforward to do. So we're being told that in our Android manifest file, this resource called app name is not found. And to resolve this is because we've moved our resources from here. So all our string values are no longer here. So we can bring back a string value resource file. So strings. Oops, sorry. Just come in here. Yeah. It's Android Studio. Okay, seems like IntelliJ doesn't want me to create a file, so what I'll just do is I'll manually just go in here, copy this, then I'll come back to values, paste this reference. Okay, I'll add this, but then the one thing I want to do is all these are not important to me. What is important to me is the app name, so that can remain, and then we can rerun this application to see what goes on with that. So meal details also had some slight issues, so let's go fix those. So I think these are minor importation issues. So string resource, again, you'll notice we're using, when you say string resource, painter resource, they're all now coming from JetBrains Compose, as opposed to Android's Compose DSL. So get that, and then fill here, and then this other one. So this is just simple resource file linking issues. This is not a big deal. And then also the imports that are not necessary. So again, string resource was coming from Android X UI resource, but now we have it coming from JetBrains Compose resource. So that's a very important thing to keep in mind. So our meal detail page should be good now. So that times the charm, I guess, I hope. So let's find out. So it does build. Took some time for me, and IntelliJ was downloading some update, but it does run. So let's see if it still works the same way. So put in a nickname, let's say Whisperer. Do that. It does load. Okay. So functionality is still the same. The UI has kept its look and feel. So still the same working application, but now our UI components are in our multi-platform package. They're in common main. So we've had our data has been moved. Our UI has been moved, and we've also moved the util. So you can delete these two temp files. That is fantastic. So let's migrate some other things. So for the UI, we can delete the screens package in Android. So now everything can be done from common main. I do have some test helpers here. So this is just a repository. So let's migrate this one. This one should be very easy to migrate. So inside our Kotlin packages, let's just go in and drag our helpers, put them in refactor anyway. Great stuff. So helpers done. It all uses common sources, so this should not give us any issue. So that goes in perfectly. So that means our data package is now useless in Android main. So let's get that gone. In the UI, we do have a few things. The theme package, that is. So we have color package, we have theme package, we also have the typography package. So I almost didn't touch any of this from the one that was generated by Android Studio. And let's see how easy it is to move these ones. So let's, since we do have here, so let's just take these here. So move those to just refactor anyway. But we I do expect a bit of an issue. So put this, let's go to project files view so that I can manually move this. So let's just use our file manager very quickly. Do I know where this file is? This is inside. Okay, so let's get that done. So let me just do it on the side here very quickly. Cool stuff. So it goes in the correct package. Honestly, if you know how to do that without the auto completion, please tell me in the comments. I always just struggle with that. So hence the need for our temp files. So for color, this moves just fine. This is no big issue. So just update the packaging. That's fine. So the color moves correctly. For the theme as well, this also will move very easily. But there's two things, something that we do need to take note of. And this comes to when we are comparing dynamic color schemes in Android. What we can do here, instead of having the dynamic color scheme, what we will do is we can have an implementation of how the theme will look on the web and how the theme will look on Android. So we will attach the following. So we will indicate a new parameter, and this parameter will be, so we have the one that asks for dynamic colors, and we'll also just do the following, similar to how our color scheme is. Let's just put a dynamic color scheme. So have that as so dynamic color scheme, which will be initially now. So for these, so this will be now, the function is what will be now. So for this, we will say, if it's not now, then just give me the dynamic color scheme. So that part will be okay. Let's optimize our imports. Everything now works well. So yeah, the theme there works great. And then for typography, I don't expect this to have too many differences. It's exactly the same one, so that's fine. So theme, color, and typography have been migrated. So let's see if our app still runs the same way, if it looks the same. If it looks the same or feels the same. So again, yeah, kind of works. So we say something like context. Let's go. And then you'll see the different things again, still the way we're using them. So it looks the same, feels the same. So that part works. So we've moved all the packages actually from being Android specific to being Compose multi-platform in a way. The last thing we now need to do is to move our main application, which is residing in main activity, and that's why it's calling all these common resources. So we move all this into our common main. So within common main, I will come into our UI and I will add one package. No, let's just do a file. Design decisions are all up to you, of course. So we'll just call this random recipes app. It will be a file, and this will have a composable function. And I'll just call this random recipes app. And get everything inside this theme and the theme itself. Everything. Get that gone. Bring those here. So wait for all imports to do their thing, and they have. And maybe the last thing we just could do is for our scaffold have the modifier be stretched from here. Modifier. So yeah. And then let us also get this out of the theme. So the repository and the view models, have them go outside the theme residence. Have them somewhere there. So in the first composition of this. So with that, our app is moved. So the only thing left now is to go back to main activity, since main activity is our entry point for the Android application. We can just copy this, get back here, and provide that import. So import that, and just optimize these imports, and we can confirm this still runs one more time. So yeah, common code is working fantastically. With that, let us remove any unnecessary files here. So we are now left with our Android main only has the main activity because it's the entry point to the app, and that is only identified from Android's context. So random recipes remains inside main activity. So main activity will remain inside the Android main source set. Sorry. Good. So with that done, we now have everything in common main. So let's move our unit tests then. We only have one unit test, so let's do the following. Firstly, Kotlin class or file. Let's get the package because we want the so I'll just use the directory, I guess, because I'll have to put in the Kotlin directory first, then a package. So this one will be the same. And I put only one file. So refactor this. I think this file also has some issues inside because of the movement of the different components it's testing and where it is being tested from. But there's some other things also that you have to keep in mind. Number one is, by default, test is not yet imported So we'll need to import that in our Gradle config for common test. So our common test source set dependencies are blank as of now. So once the build completes, when you add our Kotlin test in common test, we will head over to mill repository test and import all the broken files. Something else is still broken is our run blocking function, and we will add this with our Kotlin coroutines test library. So let's add that. So let's go to our Gradle wrapper and our Kotlin coroutines test. I'll also define the coroutines test package, version being I think 1.9. This is a stable version at this time of the video, so that should work. And then of course lastly just put that in our common test source set. So next thing now, after you've imported coroutines test, the only thing we now left to do is change this to run test. That is available. Also run test here. Yeah, so let's just import the flow params, and for us to do this, let's add our coroutines. Yeah, so it just needs importation. I don't know why it is refusing to auto do that for us, but let's just do that last. And yeah, there it goes. Can run those tests from on the Android target, and that will run it locally. So both of our tests do pass now. So they're very basic, simple tests. We're just using them to see, it's sort of like a migration guide. Now we have our test source set moved correctly, and so we can, to begin with, get rid of this source set now, Android unit test, unless we want to do something locally that we are so interested in. But for now, this can go away because now all my tests are in Kotlin and I'll use them in common test. So we'll come back to here, Android unit test, get those out of the way. You don't need that anymore. Synchronize this. Let that import and Gradle to realign. And then once that is done, we just get rid of Android unit test as package. So have this one. We would like to delete this source set. We do it bit by bit. Yep, let's do that. Delete that, and also this Android unit test. Awesome stuff. So now we will keep our Android test inside there. Just let it run on the Android emulator. But for common main and common test, those can be kept as they are. So my UI test is running specifically on my target, but all the other common type of tests are running in common. I will now I think we can just rerun this one last time to make sure everything still works as it should. So yeah, I think it's Jello or whatever name it is, and it works as it should. Awesome. We've done a lot of migration. Today we've done a lot of refactoring of code. We've moved a lot of things from Android specific related things to now a common approach What we had in part 1 was just us moving the code into the build structure. But now we have our source set up. We have our UI running from common main. We have our business logic running from common main. The only thing that is still Android specific is two things. One, the manifest file, which is specific to Android, of course. And number two, our Android tests, which currently I am opting to do them specifically on each platform differently, because each platform will behave differently. And so I'd like to keep those UI tests as they are. However, as of the time of writing this video, there was a library that was released for writing compose UI tests on common test. You can check that out from JetBrains link below that I will attach. That is it for today. We've made a very huge milestone. Our app is running mostly on common. All our UI is running on common, everything is running on common, and we will now be able to just have that run on the web with some very few tweaks. And that is exactly what we will do in part 3. So stay tuned, keep it locked in, subscribe, leave a like and a comment if you like this video. See you in the next one. Keep writing code.